Welcome to Sundar's lecture. This is lecture number 24, and in this lecture we are going to see static zero hazard and how we are going to cover the static zero hazard, as well as we are going to see dynamic hazard. So what are all the topics we have seen in the previous class? See, we have started with the propagation delay and what is propagation delay, and then we have seen what is glitches in logic circuits, and then we have taken an example to understand the glitches in logic circuits, and we have gone to static 1 hazard and how it is happening in the logic circuits, and then we have seen how to detect the static 1 hazard, we have to use the Karnaugh map so that we can easily detect the static 1 hazard, and we have seen one or two examples. Then we have gone to how to cover the static 1 hazard, how to eliminate, how to eliminate the static 1 hazard. Just we have taken an example and we have just eliminated the static 1 hazard, and we have seen one more problem to the maybe 4 variable came up, and we have seen how to eliminate this particular static 1 hazard. And in this class we will see static 0 hazard. See, what is static 0 hazard? In static 0 hazard, the output should remains at 0 according to the Boolean logic, but the glitch occurred under certain combination of input. The condition is the output should be at 0, and for a moment it will goes to 1, and for a moment it will goes to 1, and again it will comes to 0. And this is an unwanted positive glitch is happening in this particular output of the logic circuit, and that is what we are going to take as static 0 hazard. The desired output is 0, and if the output goes to 1 for a moment and then comes to 0 again, then we will call it as a static 0 hazard, and we need to eliminate this one. So what is the condition and where we can see the static 0 hazards? That is this particular circuit diagram. See, for example, let this be 0, and what happens now? This 0 will go here, and this will be 1. So if this is 0, 1, then obviously what is this one? This will be always 0, the output. And what is the equation of this one? Very simply, you can write this equation. We have already know this one. So this is A and this is A bar. So the expression will be A dot A bar. What is this one? This is actually fallacy, right? Fallacy. So what is fallacy? The output equation always 0, right? So what happens now? This 0, if this 0 is going to 1, from 0 to 1, what happens there? So for example, this 0 is going to 1, this will be now directly 1, and in the previous case it is 1 here, but this NOT gate will have a propagation delay. What we have seen in the previous class, we have explained this one. This gate will have a propagation delay, so that this one will come here and this will not goes to 0 instantaneously. So that is what a propagation delay will come. So see here, from I have made this A to 0, this is 0, I have made it to 1, but this gate is taking this A bar to 1 at particular delay, this T1, tau 1 maybe. This tau 1 is because of this delay, and what happens there? So that this one, now the input of this AND gate, for a moment it will be 1. Both inputs will be 1. And what should be the output now? It will be 1. Since both inputs are 1, the output goes to 1. So for example, what happens here? You see, this one goes to 1. The output goes to 1. And what is this T2, tau 2? You may take this tau 2 to be the propagation delay of this particular AND gate, and you can consider or don't consider, but the result will be output goes to 1 for a particular moment of this propagation delay time. And if this 1 goes to 0, then what happens? Oh, maybe I will put it in a different color. This one goes to 0, then this will comes to 0. That is what happening here. So what is this one? This is called a glitch. And example of this glitch, we can have a circuit like this. So I may write this one now. What is the expression for this one? This is C plus A, C plus A. And what is this one? This is actually A bar plus B, right? And what is this one now? This will be C plus A dot A bar plus B. This is the equation, Y equation. And what I am going to consider now, this one, C, I am going to consider it to be 0, and then B, I am going to consider it to be 0. So if so, then this equation, the output equation Y will be is equal to what? This is 0, so A will be there, A will be there, this is A dot, and this is 0, so A bar will be there. So now you see, what is this one? This is this is fallacy. So if fallacy comes, then obviously what we have seen, there is a glitch. That is called as static zero hazard. For example, the expected output is 0 and it goes to 1 and it comes to 0 again. So this is static zero hazard actually. And this static zero hazard will come here because I have a fallacy equation here. When will this happen? Maybe if you take the A to be 0 and B to be 0, C to be 0. And this condition will goes to A is equal to 1 and then B is equal to 0 and then C is equal to 0, which means if I am changing the input from 0 0 0 to 1 0 0, then a glitch will happen here. A glitch will come and that glitch will be a positive pulse like this. Maybe we will take an example. We try to do this one. So what will be this one now? This is 0, this is 0 and this is 0. So already these three are 0. So what should be the output of this one? This is 0 and this is 1 and this is 0. So again the value will be 0. So if maybe this is 1, right? So sorry, this is 1. So 1 0 input to 1 gate, it will result in 0. Maybe I will write now in a different color for the next one. What happens now? This A is going to 0 to 1. So now this A is going to 1 from 0, right? So if it is so, then what happens here? This 1 will come here. It has to make this, maybe if this becomes 1 instantaneously because there is no gate here, this output becomes 1 instantly, right? Then if this 1 comes here, this has to go 0, but because of this NOT gate, this 1 will not come as 0 here for a propagation delay. For the propagation delay, this output will be always 1. So if this is 1, then the output will be 1. So what happens now? Both inputs are 1, so this output will goes to 1. And for a moment, for example, if this is a 0 output, maybe I will put it in here. If this is 0 and for this propagation delay, this goes to 1. And if this 1 becomes 0, then this OR gate output becoming 0 because both inputs are 0. If one input of AND gate 0, then it will makes to 0, goes to 0. Then it comes to 0. So you see here, this is now 0, this is 1. So for a moment it is going to 1. So this is called as static zero hazard. So what is the point here? You need to note, whenever you have this fallacy condition for any input change, any one input change, then obviously that particular circuit will have static zero hazard. So we have just confirmed this one. And what we will do now? How to detect the static zero hazard? By seeing the equation. By seeing equation, you have to do so many things, right? You have to put 0, 1 and then only you can find this equation. But what you do? You just directly put it in the Karnaugh map. You can easily find whether the glitch will be there in the circuit or not. A glitch, which means here it is static zero hazard. That we will take examples now. So now you see we have taken an example here. So what should be this y equation? Very simple, right? So how will you write this one now? If you see 0 0, then you have to put this as now b plus c, right? So this is the equation dot, and what is this equation? It is 0, so it will be a, and then plus, what is the equation here? 1 is the common term, so 1 will be here b bar. So this is the equation, and you see, is there any static zero hazard is here? Yes, there is a static zero hazard. Why? Because you see here in Karnaugh map, if you leave any one extra grouping, combining these two groups is missing out there, then we can directly conclude it will have a static zero hazard. Yes, it is having static zero hazard. Why? Because I have left this one. This pair has been left out. That is why there is a hazard. So when the hazard happening here, why, we can easily conclude when this will be happening, because you see here it is b bar. So if a is equal to 0 and then c is equal to 0, if b is going from, if b is equal to 0 to 1, then hazard will happen simply. So you just substitute in this equation, these two equations, these two, what you will get now? So this will be b because c is 0, and then dot, this will be also 0, so it will be b bar. Then obviously b plus b bar, b dot b bar, it is parallel condition, so obviously static zero hazard will be there. So how will you eliminate this one? So add this pair. What is this one? What is the equation you will get for this one? So it is a direct term you will get, and what is the common term in these two? 0 is the common term, then obviously what you will get? C will, you will get like a plus c. So you just add multiply this term here. So y is equal to b plus c, that is one term, and a plus b bar, that is the second term, and dot a plus c, that is the third term. And if you see this one, if you draw the diagram and check it out, you will not get the hazard here. Static zero hazard will be eliminated. Maybe we will see that in the next slide. Maybe I just want to tell you whether this example has static zero hazard or no. That is the point. Yes, it has. Yes is the answer we have. And you see this one now. Is there any common term, common grouping that can be combined, that can combine these two groupings? No, right? There is no term, there is no zeros are there, no groupings are there. So obviously this example don't have the static zero hazard. And if you even write down the example expression, y is equal to, this is actually b plus c, first term, dot, and this term will be b bar plus c bar. And if you take any two terms, you see, if you substitute any values like this, you will not get, maybe, do I made any mistake? Okay, maybe you will not get it down, because if you put c is equal to 0, then what happens now? This term will be b, this term will be b, this term, but what happens to this term? This is b bar, but if you put c is equal to 0, then it goes to 1. So what is the output? It will be b. So we will not get b dot b bar anyhow. So obviously this don't have any static zero hazard. You can conclude by seeing the Karnaugh map mappings simply, right? And do this circuit have the static zero hazard? Obviously yes. Why? See here, I have missed out so many things here, so many pairs. See, this is a separate pair, this is a separate, not pair, separate grouping, this is a separate grouping, this is a separate grouping. And you see this one, I can combine these two groupings by putting a pair here, right? And I can combine these two groupings by putting a pair here also. But what you do, simply don't put pairs, because you can make this as a quad. Try to understand. Here also you can apply the simplification techniques, right? Don't put pair here, because you need to put a pair here, as well as what you need to put here, you need to cover these two as a pair, so that the different groupings can be covered. So what I can do now, but the answer is yes, there is a static zero hazard. And what is the equation? I can write down here y, which is equal to, what should be this equation? What is the common term in these two? A is the common term, so I put A. And what is the common term in these two? Again it is C, so plus C will come, put dot. And what is this term? This will be C plus D bar, put dot. And what is the common term in these two? 0 is the common term, so it will be B plus. And what is the common term in these two? C, 1 is the common term, so it will be C bar. It will be C bar. So how many combinations of the inputs has the static zero hazard? That is what you have to understand here. So how will you find that one? Actually, you see here it is C and here it is C bar. So if you get C dot C bar, then obviously there is a glitch. You can easily conclude. So how will you get that particular term? So for that, what you do, you put A is equal to 0, that one term, so it will cancel out, and you have to cancel these two terms straight away. So what you need to do, maybe what you do, you leave this one, D bar is here, so D bar means what you need to put, D is equal to 1. If the term is here, if there is bar, then you put 1. So for this one, you need to leave C only. So B should be is equal to what? 0. And if you do so, this Y expression will be what now? This Y expression will become, this is 0, this is C, so C will be there, dot, and this is also C because D bar is 1 here, so if you put 1, this becomes 0. So there is C dot, and this term B is equal to 0, so you have C bar. So what is this one? This is actually C dot C bar. So what happens now? I will just write down the expression to understand. First is A, it is 0. Second is B, it is also 0. And let C be 0, let C be 0 and D is equal to 1. And if this input changing, this one and this one, you should not change. So this is 0, 0, and when C is changing from 0 to 1, and then this combination, if this combination is there, if 0, 0, 0, 1 changes to 0, 0, 1, 1, then there will be a static zero hazard. You can conclude like that. Try to understand. What is the other possibility that I can do here? So if I put A is equal to 1, then this whole term will become 1. Try to understand. That is one possibility. And here you put D is equal to 1 again, so that this term will be whole as C. And here you put B is equal to 0 now. Right? So what happens now? If I put this one, this expression will be, this will become 1, this will be C, and this will be C bar. What is this one? This will be again C dot C bar. So what is the idea here? So A is equal to 1, maybe we will take different color. A is equal to 1, B is equal to 0, and C has to change from 0 to 1, and D is 1 here. So if this one changing from 1, 0, 1, 1, this C will only change from 0 to 1, and there will be a glitch. There will be a static 1 hazard will be there. Right? What is the other condition? Try to find. We have 3 different static 0 hazard can be happened here. You have to make this expression to be C dot C bar. That's all. That is the idea. Simply put, this D is equal to 1. What happens now? Sorry, D is equal to 0. Then this will be 1. Then this term will be cancelled out. So what is the idea? Put D is equal to 0, so that this term will be, because this becomes 1, so C plus 1 will become 1, and this term is gone out, so this C dot C bar can be taken off. So how that can be possible? So put A is equal to 0, and then here B is equal to 0. Can you understand? This is the idea. And if it is so, then what happens? This term will have C dot, this term becomes 1, and this term becomes B. Sorry, C bar. Can you understand? We have found 3 values. What is this one now? A is equal to 0, B is equal to 0, but C will change from 0 to 1. We know that one. So put this also as 0 and D is equal to 0. This changes to the A should be same, this and this should be same. This is 0 and C is changing from 0 to 1 and then this becomes 0. So these three conditions, this one and this one and this one, if the input changes from 00001 to 0011 and 1001 to 1011 and 0002 0010, if input changes from this to this, there will be a glitch. Output will have a static 0 hazard and for a particular moment you will have a 1 in the output. Try to understand. So this is the three conditions. You have to find it out. The ultimate aim is to get C dot C bar from this expression. You will get it now very simply, right? So even if you find this one, maybe you can find out by simply seeing this Karnaugh map. Yes, I have missed so many pairs and quads are there to combine any two groupings. There itself I can conclude that there will be a glitch or a static 0 hazard. But when it will happen, that is this explanation. When it will happen, that is the explanation I have given you here. So how can you eliminate this one now? Very simple, no complications here. That is what I have came here now. See how will you eliminate this one. Maybe I will explain things for only one example so that you can easily understand and you can go for the other two examples, right? So I will write down the expression. I have just taken the previous one. This is the expression, right? Y is I have already taken this one, right? So y is equal to, I will just write it down. So this is the expression. This is the expression. I will draw the diagram so that you can easily understand. See here, I have just taken the example and I have just drawn this diagram now. So this circuit as a glitch when input changes from 000 to 010. So what happens now? This one is 0, this is also 0, this is also 0. So the output is 0 and this output is 1 and then this is 0. So this is also 0. So ungate output will be 0. So the output should be 0. There is no change. The output will be always 0. So what happens now? This B will change from 0 to 1 now. So I will put that in red now. So what happens now? This B is changing from 0 to 1. So this is changing from 0 to 1. So what happens now? This OR gate output will instantly changes from 0 to 1. Sorry, you see here, this is the OR gate output. This is all 1, right? This is already 1. So I made a mistake here. So first time itself it is 1. So this one is 1. So now what happens here? So now for an instant, this NOT gate will take a propagation delay. That is what we have already seen. So both inputs is 1. So this output goes to 1. And after this propagation delay, because since it is 0 to 1, so 1 will come here. So this will goes to 0. Then what happens here? Then obviously there is a glitch. So this one will again goes to 0. See, try to understand, there is a glitch here. There is a because the expected output is 0, it goes to 1 for a moment and then it comes to 0 again. So static 0 hazard has been found here. So how can we eliminate this one? Make this pair also into account. What is that pair? That is what I have already told you here. So we will draw that diagram now. So this is the equation. For this equation I will draw the diagram. So see here, just I have drawn this diagram and I am going to explain the same condition when input changes from 000 to 010. So this is A, B, C and this is A, B, C, right? So first I will write down for this one. So this is 0, this is 0, this is 1, this is 0 and this is 0, this is 0, right? So what happens now? This output is 0, this output is 1 and this output is 0. So here the total output of this circuit becomes 0 because this is 0, this is 1, this is 0 simply. So now in the previous case, if this B is changing from 0 to 1, then this gate makes this output to 1. But what happens here, even if this NOT gate is taking time to change this 1 to 0, 1 to 0, so that the problem has been created in the previous circuit, this output is 1 for a moment. So this is 1, this is 1 for the second case I am saying. But the output will not goes to 1 because this A plus C here, this input has not changed. So there is no change in these two, this will remains in 0. So even if these two comes to 1 for a moment, but this particular gate making the output 0. So this, because of this one, the glitch, during the glitch of this particular gate making the propagation delay, the output is maintaining at 0 because of this one. That is what we have added here, multiplied here anyhow. So what happens here? The static 0 hazard has been eliminated. So this is the idea. See, we have deducted the static 0 hazard here and we have eliminated by covering this two groupings with an extra pair. With extra grouping, maybe it is not restricted to pair, it may be quad. If there is any quad possibility, then you have to go to the quad possibility, right? So you see here, I have taken this one and we have already seen this one, this example. So this one I will just copy down. So in this circuit, for this equation you will get a static 0 hazard, that is what I have already told you. But now you have to cover these two groupings. So these two groupings can be covered with these two zeros can be covered as a pair. You just try to understand me. That is also possible. And these two also covered using these two. That is also possible. And also this one and this group can be also covered. For that, what I am going to do now, I will make this whole quad into account. For these two covering these two, this also can be made like this as a quad, right? So what is the extra term you got here? Oh, that's all. We have covered every possibilities we have done now. For every groupings, you have just made a possibility. So what is this one now? This output will be it is 0 0 means what is this one? This is A plus B. That is one thing. And what is this one? For this grouping, what is the value? What is the equation you need to write? The common term in these two, it is 0 0. So it is B plus, what is the common term in these two? One is the common term, so it will be D bar. So what should be the output equation now? To make the hazard free circuit for this particular expression, static 0 hazard can be eliminated for this expression. So it is A plus C dot C plus D bar, this one I am writing, dot B plus C bar dot, you need to write this one also, A plus B dot B plus D bar. So if you draw this circuit and just verify, you will not get the static 0 hazard. That's all, right? Can you understand? This is how you need to eliminate the static 0 hazard. So what are the topics we have seen in this class? See, we have started with the static 0 hazard. What is static 0 hazard? The expected output of the logic circuit is 0 and for a moment 1 will come in the output of the logic circuit and it goes to 0 again. And if it is so, that is called as the static 0 hazard. So why it is happening? Because of the propagation delay, right? We have taken an example to understand the glitch, positive going glitch, and that is called as static 0 hazard. And we have taken examples to detect the static 0 hazards. 3 examples we have taken, and we have just covered this one. How to cover the static 0 hazard by putting extra pair or quad in the grouping of the Karnaugh map. And we have taken this example also to understand, right? Thank you.